Cartograms. Make sure my extensions are turned on. Yep, they're turned on. Okay, let's add my toolbox. Okay, that's something we need to do right first before we actually use the cartogram tool is get rid of any no data values that we're going to be looking at. So let's take a look. Almost universally in data sets like this, you'll have some issues with places like Antarctica or Vatican City or something, okay? Okay, well that's good. It's got zeros instead of negatives, so let's give it a try. Okay. Choose the CO2. Choose an output. I think it has to be a geodatabase in this tool. Working temp, right? I think your temp is uppercase. Make an output to geodatabase just to make it easy. Okay. Each field is uniquely defined by an ISO. Might not actually be needed in a geodatabase, but we'll do it anyway. And in a geodatabase, again, you can do shape area, but we'll do. Another one to do. Square kilometers, square miles, doesn't matter, right? And that's the size of the mesh, okay? So it's 512 by 512. They make a mesh over the whole planet, calculate the density in the mesh between 0 and 1, and that's how the cartogram's adjusted. Well, the Earth's 360 degrees wide, right? So maybe a good number would be to do a multiple of that. Let's give 720 a try here. Oh, didn't like 720. So let's go back to 512. Might be a logical number. It has to be like 512, 1000 to 24, something like that. Okay, so got cartograms, the sample, right? And one of the things this latch will also do is reproject a relative image. So this is the NASA grid, okay? Reproject a background or something, okay? While you're also doing the main projection. There might be some other options you need to choose down here on your one, but that's basically the fundamentals of creating a cartogram, creating mesh size, the algorithm it uses. The tool help probably doesn't work because we haven't loaded it into the help area. Yeah, we probably haven't loaded it into that location, but it's there actually in the cartogram tool if you want to look at it. Okay, so let's give it a whirl. Now let's check how our process is going and results. Okay, so there we go. Got a little warning message there. Let's see. Yellow means warning, so these polygons smaller than the mesh, yeah. So we lost some very, very small places again. Places like uh, Vatican City may disappear in other city states. Okay, so it's pretty cool. Wonder if it did our background. Particularly good representation between the global. Yeah, it worked perfectly, didn't it? It's a particularly good representation difference between the global north and the global south, and that can be a solid use for a cartogram when you have such extremes. Okay, so we can also render the information if we so desire. bit of symbology, okay? Quantities, right? CO2, okay? See how our histogram looks? Heavily skewed, right, with one big outlier, so we might want to switch our system there, okay? Get for some more breaks down the end, okay? This is really only this one that lasers out, that extends it out that far to the right, okay? And as you can see, it's all pretty dark when we do that, and that's because the smaller countries you can't really see because they're the lighter colour. They are all there, so might get something a bit better off a break. So let's take a look at that. Look at the Jenks system. But it is kind of hard to render cartograms because, yeah, that's a bit better, isn't it? It is hard to render cartograms because they do exist, all these small yellows, even in the quantile system. They're just too small to see, right? So there's a cartogram. Don't use a scale bar. If you're forced to use a scale, use a representative fraction, you know. So that'd be the number like up there and round it up. Rest of the map elements can go in it, okay?